Today we are learning how to find the slope between 2 points, and we're going to use the slope formula. We've learned some things about slope already. We learned that slope can be represented by the letter m, and it is a fraction where you have the change in y and divided by the change in x. You could also write it like this, change in y over change in x, where the change is a triangle. And on a graph, you can say it's the rise, or how much it goes up, over the run, how much it goes to the right. We also learned that when you look at lines, you can tell if they are positive, negative, zero, or no slope, which I use the word undefined. Both of those words are correct. If it goes down as you read from left to right, then it's a negative slope. If it is stable, if it's flat, then it's a zero slope. And if it goes straight up and down, that's no slope or undefined. And if it goes to the right, as you read from if it goes up, if you read from left to right, then it's a positive slope. So you should be able to know just by looking at it if it's positive, negative, zero, or undefined. We learned before how to find slope from a graph, but we're not always given a graph. Sometimes we're only given 2 points. We could graph points, but we may not have graph paper, and the numbers might be really far apart or really hard to find. In these cases, it's nice to have a formula where you can just plug the numbers into, and that would give you the slope. We're going to develop this formula by what we know from finding slope from a graph. Just as a review, when you're plotting points and when you name what those points are, the first coordinate is the x coordinate, and the second coordinate is the y coordinate. So on both of these, it's x, y, x, y. When we plug these numbers into our formula, it doesn't make sense to have x both equal 5 and 1. So we're going to say that one of them is the first x and one of them is the second x. So I'm just going to pick this first point as the first point and label the bottom 1. And on the second one, I'm going to call that the second point, so it's going to be x2 and y2. Now you may confuse this with this. Remember that x with a 2 above is x squared, or x times x. So this one is a mathematical operation, but when you put it below, for some reason mathematicians are lazy and they just changed where you put the 2. This one is just a name for it. It's just a name that it's the second x. But that other one, don't be too confused, means that it's x times x. So on this one, we're not multiplying it by itself. We're just saying that's the second one. All right, so now let's plot our points so we can find the slope and develop our formula. I'm going to find x1. So this is 1, 1. I go 1 on the x-axis is here and 1 on the y-axis is here. So the point where those two lines would meet is there. That's 1, 1. Then 5, 3 is 5 on the x-axis, 3 on the y-axis. It's there. Now, when you're graphing to find the slope, you don't need to have the line there, but I'm going to draw the line just so you know what it would look like. Lines in mathematics go forever in both directions and have arrows at the end. I'm sorry mine doesn't look that straight. Hang on, let me see if I can get it straighter. Okay, there we go. So there's my line, but really all I care about is this portion because that's what I need to find the slope. So I'm going to draw my slope triangle, and I always pretend it as here's my house, here's my friend's house. I'm walking to their house. So I walk up first and then to the right. When I go up, it's up 2. So up is a positive direction, so that's a +2. When I go right, it's a positive direction, and that's right 1, 2, 3, 4. Okay, so now to make my fraction, it's change in y over change in x, or rise over run. So we went up 2 in the y direction, and then we went 4 in the x direction. And when I simplify that fraction, I get 1 over 2. Now let's see if we can come up with a formula for how we got these. When I got my 2, yes, I looked at the graph and I counted the spaces. But if you look over here at the axes, you have 3 and 1. and I can subtract 3 minus 1 to get 2. So I'm going to make this black because this is my formula work. 3 minus 1 got me 2. And then over here, I went this way. That distance is 4, right? And that's 5 minus 1. 5 minus 1. Okay, and 3 and 1 were both y's, and 5 and 1 were both x's. So let's go ahead and make the formula. We're going to subtract our y's and our x's. And when I labeled them, 3 was y2. If you see it right there, there's my y2. So I'm going to put in my formula y2 came first, and it subtracted y1. And then x2 came first. It did, right? X2 was the 5, and the 5 is right there. Okay, so x2 came first, and then it subtracted x1. This is my formula that I can use always. Y2 minus y1 and x2 minus x1. And the important part is that when you have your points, I would label them every single time, label them x, y, and then put one point as both the 1's and the other point as both of the 2's. All right, let's go ahead and try out this formula. I'm going to find the slope between these 2 points just using my formula, and then I'll check on the graph. Okay, my formula was y2 minus y1 over x2 minus x1. All right, I don't know what those numbers are yet. I need to label them. So I'm going to label this xy and this one xy. And I choose this one to be first and this one to be second because it's just easier for me to write it that way. Now let's plug in our numbers into our formula. Y2 is negative 2. Then we're going to put minus y1, which was 4. X2 is 1, and then I'm going to have minus x1, which was negative 2. Now this is super important. The minus is always going to be there. So if you want your number that you're subtracting to be negative, then you need to make sure you have a minus sign and a negative sign in your formula. Otherwise, you'll get the wrong answer. Okay, so we have negative 2 minus 4 on top. That equals negative 6. And 1 minus negative 2 on bottom. What's that? 1 minus negative 2, 3. I would recommend on ones like these with a lot of negatives that you enter them into your calculator. This is surprisingly the place where the most mistakes are made. Okay, so places where mistakes are made. This part where people forget to put the negative in there as well. And then the part where you're just trying to figure out what it equals, and sometimes people forget how to subtract with negatives. So negative 6 divided by 3 is negative 2. So my slope is negative 2. I know from a slope of negative 2 that it should go down as I read from left to right, and that it should be kind of steep because it's not a fraction. All right, let's go over here. We're going to graph our points and see if we're correct. Negative 2, 4 is right there, and 1, negative 2 is right there. So here's my line. It is going down as I read from left to right, and it is pretty steep. So I think it is negative 2. And if you were to draw your slope triangle, you would find that it does indeed go down 6 and over 3, just like we got in our formula. So here is the kicker. If you have a graph, use rise over run. If you have 2 points, then use this handy dandy formula we created, y2 minus y1 over x2 minus x1. And the thing that always works for you to remember is to think of the change in y over the change in x. Okay, we're going to go ahead and do one example, and I'm going to show you what happens if you change which point you decide is first versus which point you decide is second. So we're going to make this one be first in purple. I don't know why I labeled that as y. x1, y1, x2, y2. Let's make this pencil a little skinnier. Okay, so when I write my formula, let's do this over here. y2 minus y1 over x2 minus x1. Yes, I've done this for years and I still have to say it every time. So y2 is over here, so it's 6 minus y1 is 4. Okay, and then we have 4 minus 3. Oh, no negatives. That's nice. Okay, and we get 2 over 1, which simplifies to 2. Okay, so let's change this up. We're going to say that the first one is second and the second one is first. And we're going to do our problem in blue now. So we're just swapping them. This may look wrong to you, but we're going to see if you could choose either point for it to work. Okay, my y2 is 4 and my y1 is 6. My x2 is 3 and my x1 is 4. 4 minus 6, this might be a good place to use your calculator. 4 minus 6 is negative 2. Okay, that looks different, so I'm a little worried, but let's see what happens. Okay, and then we had 3 minus 4 on the bottom, negative 1. Now, a negative divided by a negative is a positive. So negative 2 divided by negative 1 just comes out to 2. So I got the same slope both ways. It doesn't matter which one you choose. However, it does matter if you flop which one is which. So if you can imagine that if you were to have done these in reverse order, then you would have ended up with a negative slope, and that's not correct. So make sure that you label and you're very careful, and you make sure that you have the first point, the second point is always right there, and the first point is always right there. All right, that's how you do it. Good luck.